It's a great honour to be able to come and talk to you. What I'm going to do today is try and present a view of bringing the natural environment into economic decision making, which is consistent with economics, but also tries to draw upon contemporary environmental science in a very integrated way. The group that I lead in Exeter actually has more non-economists in it than economists by quite a long way. We're about 2/3 natural and physical sciences and 1/3 economics. The rationale for that is that perhaps regrettably, but economics seems to be the way that most decisions are actually made. And therefore, if we want natural science to actually have an impact upon real-world decisions, we need to talk the language of decision makers. I'm going to structure the talk really in two parts. I'm going to start off assuming that there's not many economists here. In fact, are there any economists here? One, okay. Two, three, four, oh, fantastic. Okay, that's a bigger proportion than I was expecting, but still very clearly a minority. So I'm going to start off really quite conceptually and quite low level, introductory level, talking about the concept of the environment from an economic standpoint and bringing the two together. I'm then going to illustrate that in practice, and I'm going to use some work which has actually been adopted by the government back in the UK, which is absolutely crazy in most ways, in that it's pushing Brexit. I've just realised this is being filmed, and I shouldn't say that. But in other ways, with regard to the environment, it's actually doing some pretty good stuff. Okay, so I want to start from two absolutely inescapable facts. And if you accept these two facts, and they are facts, then everything else has to follow. And they are really simple facts. And the first one is that human wants, including even nice things, trying to be good to the environment, trying to be good to each other, they exceed the resources available to satisfy them all. Okay, we have this one world. It's not getting any bigger. We seem to have an infinite series of human wants. Therefore, our wants are resource constrained. We can't have it all. And that means that you can never just say, I want everything, which means there's always, as I say here, trade-offs. Because of these trade-offs, every time we decide to do one thing, we are in effect making the decision not to do something else. That has to follow from the first one. Which means that unless you're making your decisions in a totally random way, you must be using some sort of values here. You must be saying, the thing I'm deciding to do is better than some alternative thing that I could do with these resources. Now, this means that valuation is unavoidable. It's the essence of decision making, and pretending otherwise is just irresponsible. I think that we should be explicit about the values that are inherent in all decision making, and recognise that all decisions involve trade-offs, especially those involving the natural environment, because the natural environment is a system. You push the environment at one place and something else bulges out in another place. It is a system. There is never one effect. So, yeah, I've already said I'm very pro-EU, but one of the worst policies in the EU has been the Common Agricultural Policy, which has a single focus, which is just produce food. And as a consequence of just pursuing that one focus, it's generated a whole host of unexpected co-trade-offs which actually have been very deleterious, very bad. Okay, so what is the economic way of looking at the world? Well, it ultimately says there's two resources. This is one of them, and a long, long way away from it, there is another resource. Fortunately, at just the right distance for us to actually inhabit this planet. And all we have to do is leave these two resources alone, and they generate an amazing array of what an economist would call natural capital stocks. Now, those words have real meaning in economics. Capital. Capital is simply something that has the ability to generate well-being. So you have financial capital, you have machinery capital, you have human capital. And all these are stocks of a resource that can generate benefits. And that is what a capital actually is. But this one's really unusual because it's not created by us. It's created by nature, which is amazing. We get this for free. All the other types of capital, we have to actually invest some effort or resource into. This one turns up for free. So that's an amazing deal for us. This capital, if you just again leave it alone, generates what all capitals do: a stream, a flow of services. This is true of all capital types. Machinery. Machinery actually has no value at all other than the stream of services it provides. Otherwise, it's just a lump of metal. Okay, so we've got all these service flows. And again, if we leave things alone, we get the most unusual of resources in the world, and that is biodiversity. And it's unusual because it is everything. It is a capital stock. So it is a stock of future services. It is a service itself. And most unusually, it's also what we would call a welfare-generating good. So it's absolutely everything. It's capital, flow, and benefit, if you like, all wrapped in one. And of course, through the miracle of evolution, we reach the pinnacle of evolution, which, in my opinion, we have not reached yet. But anyway, we believe that it's that. So, how do we formalise this? And I'm not going to, actually there is one slide with equations on, but this is not it. I'm going to do it virtually all in pictures. Okay, so we already know that we've got these resources here generating nature's capital. Amazingly, you just leave it alone and it generates all these incredible processes, completely free of our input. Things like nutrient cycling, water cycling, the climate regulation. These are the most valuable processes on the planet. And they all happen without our intervention. Okay, they then generate these services, which we call ecosystem services, but you might, for an economist, might just call them inputs. Because these are not actually the benefits of the environment. Typically, those benefits, those goods, actually arise when we combine nature's capital and its services with other types of capital and services. And that's when we get good things, which economists call goods. And these goods are absolutely fundamental to our well-being. There is a problem, though. They come in a whole range of different units, radically different units, that are very difficult to compare with each other. We know that these things here are all really important, but look at all the different units they turn up in. Actually, it's much worse than that. Here's an assessment that we did at the start of the year for the Rockefeller Foundation of just one group of these different metrics. So you see these metrics here, all these different ones, and it's just for things to do with health. How on earth does anybody ever make a rational decision when you have limited resources, when you have all these metrics? They're non-commensurate. You know, you're comparing frequencies with risks, with tons, with cubic meters, with depression. I mean, how do you do this? How would you do it? If you were king or queen of the world, how would you do it? I think you would try and recognise, well, first of all, I can't have everything because there's resource constraints. So I'm going to try and work out which ones I need more of and which less of. I need a bit of all of them, but I've got limited resources. In other words, you're going to try and work out which ones are more important than others, which ones are more valuable, which one's more beneficial. Okay, you're going to need a unit of benefit, a unit of value. And actually, I don't care which unit you use. Use any one you like, but it's got to apply to them all. Because if you, as soon as you go from more than one unit to 2 units to multiple units, you can see the problem that happens. Now, all that economists attempt to do is try and put everything into one unit. And it's not a very good unit. This is not a great unit. But all the other units are even worse. That's the only argument for it. I've seen people try and do this all in joules of energy. They get into real messes when you look at all these things. How do you look at things like some of those things on the side in joules of energy? It just doesn't work. So, this imperfect unit has this one attribute that all the other units are worse. Okay, how do we actually try and put these monetary values on this array of different benefits? Well, there's loads of methods that have been developed. These methods, some of them go back more than 100 years now, but all of them, all of the ones there, have been researched on for at least 50 years now. This is not new stuff. Now, there's loads of reviews of all these methods. But, you know, and I'm not going to go into it in detail, but, you know, there are things like, obviously, market prices. Okay, that's fine. When you've got market prices, that's fine. But many things to do with the environment are not things you can go and buy in a supermarket. Okay? Production functions. Look at the effect that the natural environment has on the production of goods. People use that for pricing pollination services, for example. Revealed preference. Look at the fact that people's purchases of other goods are very strongly related to the environments and the environmental benefits they get from them. So, you know, if you buy a house, you are definitely going to be swayed by the environment around that house. And you're going to pay more for an environment that you prefer. All right? Stated preference, asking people questions about things. I have to admit, I've done more of this sort of research than anything else. People never read what I write. They think I'm really pro this. Actually, if you actually read the papers, they're all very critical. And they say most of the time people can't actually do this. If I ask you how much you're willing to pay for preserving the pelican, you haven't got a clue. I haven't got a clue. Why should I think anybody else has got it? So generally, I'm not that keen. And then cost-based approach is not a wonderful approach, but sometimes it's the only one available. All right. So there are many methods, and they work for just about everything. There is one thing they don't work for, and that is wild species biodiversity. Why? Because all the other things here, you can see, at very worst, you can see people behaving in response to them. So, you know, you can definitely see people behaving with regard to mental health. You can see them behaving with regard to flood defence, that sort of stuff. There's aspects of biodiversity you can't observe the values for. So yes, you can observe things to do with pollination. Yes, you can observe bird watchers and that sort of stuff. But I am very keen on preserving the polar bear. But I don't like being cold. So you will never see me going to see polar bears. Well, certainly not in their natural habitat. So there's no behaviour that you can observe. And yet it's a real value. Now, in theory, you could ask me these stated preference questions, but I don't know what my willingness to pay for a polar bear is, and I doubt that any of you do. So we have a problem with regard to that. And what I'm going to do, and I hope that there's a lot of mathematicians here, is what I'm going to do, basically, is say, right, let's put everything else into the same unit, and then I'm going to use this as a constraint. And I'm going to impose constraints that I'm pretty sure people would be happy with. For example, no loss. All right? Now I can optimise all of this subject to that constraint. Yeah, happy with that? That's the great thing about talking to scientists. They understand that straight away. I do that with a bunch of social scientists and it's just a riot. You know, what are you talking about? Anyway, okay. I'm very concerned that this is being recorded now. All right, so we're going to quantify that and use it as a constraint. All right, we've now got measures of value. Imperfect, not great, but a heck of a lot better than using all these weird units here. We can put that into a decision-making system. There might be many other things that we want to include in that. Maybe we're interested in who's getting the benefits. Who's bearing the costs? But nevertheless, we've now got a much better way of making decisions. All right. Now, I just want to point out what you've really got here is a flow of resources this way and a demand for resources that way. And it's that interaction of demand and supply which really determines why the world out there is the way it is. Because we don't have infinite supplies and we do have certain demands that people like and other things they're not that bothered about. And it's the interaction of those two which explains why Paris is the way it is, why London is the way it is, all around the world. Okay. Now, there is one thing in here that I haven't talked about, and that is the idea of sustainability. You can see that let me just go back here. You can see that what I'm sort of looking at here is something that sort of says, right, value everything. Okay, there's a constraint, maximise those values subject to that constraint. All seems pretty easy. But there is a problem. And that problem is that, okay, is illustrated as possible. The last 200 years, the previous speaker talked about this, has seen a substitution of capital types between this side, nature's capital, and this side, human and manufactured capital. Big change over the last 200 years. There's less of this and more of this. Okay. Maybe that's okay. But, okay, it's all right. No, so it's okay. I think I just need to point it better. Sorry. What if we run this down too much? There's aspects of this which is vital for us to continue living. There is not infinite substitutability between this capital and this capital. There's a limit to how much we can do it. And therefore, we need to have a sustainability analysis in here as well. We've got to be careful. We can't just maximise, we can't just do a constrained maximisation of benefits here without recognising that if one of the ways that we get those benefits is to run this down to critical levels, that's not a good idea. So this is where you can link to these ideas of planetary boundaries. So One of the things that we have to add to this is sustainability rules. We have to look at these two types of capital and make sure, at very least, that future generations should have the same opportunities for well-being as we have. Now, there's many variants of this, and I'm going to go on to the two most important ones, but one very obvious one is that the sum of these capital stocks shouldn't decline over time. There's others that we can do, and I'll come on to that. The second bit of this is some sort of cost-benefit rules. And these might seem really, really obvious things to say, but you'd be amazed how many times these really simple rules are not actually implemented. The first one is consider all the benefits and all the costs. So if you're going to have an agricultural policy, don't just think about the food it produces, think about the fact that it's going to pollute the waterways, that it's going to emit massive amounts of greenhouse gases, that ammonia is going to go through the roof. You can't just look at the benefits of the thing you want and ignore the physics of all the other things that are going to happen. Secondly, you've got these limited resources. Think about doing other things with them. Don't just say, we are going to do this, without thinking, well, hold on, that means we can't do something else as well. And obviously, make sure that the benefits are bigger than the costs. Okay, you go into appraisal, you make a decision, you implement it, the whole thing goes round. All right, I want to just very quickly show some good things that are happening in Britain. There's not much at the moment, but here's two little ones. One is that there is a movement to long-term planning, massively overdue. So, like most of the countries in the world, we have planned our environment and its policy on an electoral cycle. What can we do ahead of the next election? Well, the environment doesn't work like that. The environment is not interested in when your policies, your little party political debates are going to come up. You've got to work on a longer basis. Really, you'd want an even bigger policy than 25 years, but this was a political compromise, and you can see that it has actually been accepted. So that's great. So this is the basis of environmental policy in the UK. Yes.
When did it start?
This started in 2018. Yeah, and it's already not. It's not having. I can't say, oh, it's already working. What it's doing is showing all the failure that's going on at the moment. So after 1 year, they assessed progress, and they found they didn't have the measures to assess progress. They didn't know if it was improved or not. So I suppose that's better than not even realising you don't have the measures. So, yeah. I am not giving you some idea that the UK is a great nirvana place. But anyway, this second very boring document is actually more important. And I'm going to, because it's more important, I'm going to flick onto this slide which gives you more detail. It says about two things. First of all, it says you have to recognise that when you change things in the environment, multiple things can happen. It's not just that you have a policy for food and therefore you measure the amount of food. You think about the other things as well. And then the second thing, which I think is fantastic, I do think this is pretty good, is think about the stock levels as well. So think about the costs and benefits, but also think about the stocks, and particularly, this document is not from the Environment Department. This document is from the UK Treasury, where the real power is. To be honest, I mean, it's probably different in France. I'm sure France is fantastic and makes its Environment Department more important than any other department in government. But in the UK, the Environment Department is right down there, and the Treasury is right up here. And what the Treasury says matters. And this is the Treasury document, and it says, I mean, I'm amazed that a Treasury document can to say these things. There might be these things called ecological tipping points, where stocks might suddenly collapse. Okay. I want to very quickly talk about how we can perhaps do this in practice, and talk about a particular tool that's been developed called Nevo, which actually attempts to look at all the consequences of making a change in policy. So first of all, it says policy isn't the only thing that causes things to change. Yes, policy is important, but there's also an economic market out there, and prices go up and down, and that affects land use. But also there's an environment, and it varies massively across locations, but also, very sadly, it's now altering across time as well. So all these things are inside this tool. It then says, okay, you've got all these scientific relationships, but they then feed into a lot of economic relationships. This is basically a load of models all programmed together. And some of those relationships result in values which occur in markets and have prices. But be very careful, because there's a whole load of other values that occur outside markets, and they're very important as well. So all of these are included in this model as well. In fact, this is the whole architecture of it. All I'm really trying to show there is there's lots of different models all linked together here. And they look at things like water quality and flooding and biodiversity and carbon sequestration and pollination and all these sort of things. If you're interested in using this, it's free, it's online. You can go to it and you can just play around with it. If you want to find out where it is, here it is. So it's at the institute that I run, and you just type that in. In fact, if you just put in Exeter and Leap, spelt in this unusual way, L-E-E-P, you will come to the front page here, and on the very front page, you will see this tool, and it's all free, and you can just play around with it. And I think you might be quite surprised at what it can do. If I get time at the end of this, I'll demonstrate it working, but I don't know if we'll be able to. Let me instead go through some of the elements of this modelling system and show why it's an attempt to do this properly. I'm not saying it is perfect at all. It's a long way from perfect, but at least it's going on the right line. So the first thing is, one thing we wanted to get away from was the sort of analyses where we come in and we say, okay, this is the world at the moment. Suppose the world was different. Would it be better or worse? We're not very interested in those sort of analyses, because even if you get it right, a decision maker will then say to you, well, how do I get from here to here? And if you can't answer that, they're not going to listen to the rest of what you say. So a large part of this is to actually build models which allow the decision maker to say, well, I don't control the whole world. I only control a few things. You know, I might control my agricultural policy, I might control my environmental policy, but I don't control prices. I definitely don't control the weather, you know. So it allows you to actually change those things that you can change. And all the other things are in there changing as well, but they're not determined by you. Prices are determined by international trade, that sort of stuff. It's got all the soils and all that sort of information on it, and it's got a lovely climate model, which is not ours. It's the UK Hadley Centre model, which underpins a lot of the IPCC work. Okay, what is the... now, that's the only... You don't want me to go through that, do you? It doesn't matter what this is. If you want the papers, I'm very happy to give them to you. They've got all this sort of Greek rubbish in there. All I'll say is they're published in really good places, they went through a review and all that sort of stuff. What's more important is to just ask, do they work? Okay? And you can see whether they work or not by simply doing what is called out-of-sample validation tests. So what you do is you take all of your data. You might have, well, in our case, we've got data from about 1964 to the present day. And we've got it at a very high spatial resolution. So some of this data is held, well, actually some of it is held at a couple of meters resolution. Some is held at higher resolution. Okay? But it's a very big, very long data set. So you take your data and you take some of that data and you put it on one side. Okay? Let's suppose we look at the most recent years, we put it on one side. We go back to the big sample of data and we build our models. Okay? We then test if they work by taking those models and getting them to predict for the data that we put on one side. And we then compare that prediction with what actually happened. That's about the best sort of test that you can.
Say again what your sample is. And
sure, yeah. So it's from 1964 to the present day.
That's a sample. What is our sample?
So that's the entire sample. And for every year we have thousands, tens of thousands of observations for all the areas around it. We take that big data set, okay, and we say, right, let's look at, say, the last 5 years, okay, and I'm going to put that over there, and I'm going to leave it over there for the moment. I'm going to take the rest of that data, and I'm going to build my models using that, okay. I'm then going to use those models, based on the past, to predict what happened in the last 5 years, okay? And when I do that, I find that...
Is there a lot of change in the last 5 years with respect to the previous 20 years?
So I control for those things that are in the model. So, for example, if the prices change historically, and we know the prices have changed now, yeah, I can say, all right, let's use the prices now, okay? Climate is a really interesting one because climate has changed, it has changed in the past. It's now changing now. It's only 5 years though, it's not going to change that much, but nevertheless we still use the most up-to-date figures for that. Okay. And when we do that, we find that the models fit really well. They are very good at predicting. Now, because they're good at predicting, that means that if we now reassemble the data, we've got the whole stretch, and build the model out of that, the models can only get better because they've got more data now. Yeah? Now, because we feel happy about these models, we can now use them to project into the future and say, okay, now what do we think is going to happen in the next 10 years, all right, if climate changes a bit more, or if climate changes and policy changes, or if climate changes, policy changes and prices change. Because you've got a data set that is built on millions of data points, you can ask these sort of questions. Okay. And you can ask questions like, what will happen, what will the consequence be of climates changing? All right? So we know that climates are changing. In fact, I would say, as an economist, that we know more about the future of climate than we do about most other things in the world. So there's all this debate about, how certain are climate change estimates 50 years into the future. Okay? Is it there, or is it there, is it there, or is it there? Okay. There's some uncertainty. But that uncertainty is nothing like the degree of uncertainty about things like what's the future of the price of wheat going to be. We have no clue. Why do we have no clue? Because technology is changing so rapidly that we don't even know if the price of wheat will go up or down in the future. We know there's going to be more people. That would probably push prices up. We know that there's going to be climate change. That would also, you would think, push prices up. It's going to dislocate historic production. But we also know that technology is changing at a rate which is very difficult to predict. It might be, for example, that in 50 years' time, we don't grow food outside. It's perfectly reasonable to think that. We've already got to a situation where if you compare the average production in the UK with the average production in the Netherlands, a lot of which is grown indoors, the Netherlands has 14 times the productivity level of the UK. That's a big difference. So I'm pretty confident about the climate models. I have no clue what's going to happen on prices. So in what I'm going to show you now, I'm going to assume that in real terms, taking account of inflation, prices are going to stay the same. I can, of course, change that assumption, and it has big impacts. But just be aware of that. Let's just look at the effects of climate. Now, this is the UK, all right? This is the situation. No, it's not working. Okay. Well, over here you can see the temperature at the moment and the temperature in the future. Here's the rainfall at the moment. Here's the rainfall of the future. How many of you been to the UK? Okay, yeah, quite a lot. Yeah, it's wet and it's cold. It's not very nice. It's not. I come from there. Believe me, I have to live there all the time. It's wet and cold and not very nice. But in the future, it's going to be great. It's going to be fantastic. It's going to be warm and it's not going to rain so much. Lovely. Fantastic. It's going to be nice for me. It's also going to be nice for crops. They're going to like it. Of course, climate change is going to be really, really bad for the world. But hey, and here we're going to be fine. So don't be surprised when I say that actually climate change is actually going to be good for UK farming. It's going to be bad for the world, good for UK farming. So, what's going to happen into the future? This is the situation at the moment just for two activities, just to illustrate. We've got all the different activities in the model, but here's just two, cereals and beef, and you can see what the situation was a few years ago. And basically, the light colours means there's lots of it, and the dark colours means there's less of it. Okay? So what's going to happen as the UK becomes warmer and drier? Well, we're going to get more cereals. Just as you'd expect. Why is this happening? Well, it's happening for two reasons. One, obviously, it is warming up. The rainfall isn't so bad. And therefore plants are growing better. But actually, as an economist, I have to say this to justify my existence, it's going to change the profitability of different activities. So it's actually the two together. It's the climate change, but also how that changes the economics. So what you're seeing here is cereal production becomes more profitable into the future, and so you get more of it. Now, that's good if you're a farmer, because you're going to get richer. But it's going to have some pretty bad impacts on other aspects of the environment. And one is the water environment. A switch from grazing to cereals will be accompanied by more and more inputs, in particular nutrient inputs. And that's going to result in a lot more water pollution, particularly in those areas where it's very suitable for growing cereals. That in turn feeds into another set of models within this modelling suite, which tells you about the ecological consequences of this. So we're going to get more eutrophication in UK rivers. That's going to be very bad for the flora and fauna of those rivers. What are the sort of impacts that that's going to have? Oh, this is a bit... Okay, this is running through an apple. It's been written on a on a PC. It's moving around a bit, but it's okay. So there's going to be lots and lots of effects. Here's two just to illustrate it. One is it's going to change the cost of water. We're going to have to treat water a lot more. It'll also, that's a bit boring. You can see how we would work out the values of that. More interesting, more of a challenge is how is it going to affect some non-market values, for example, recreation. And this allows me to illustrate to you quickly how economists can come up with numbers that aren't crazy. We're very good at coming up with crazy numbers, but sometimes we can come up with some numbers that aren't crazy. So one is, how do you value outdoor recreation? Okay, so you start off by saying, let's find out where people live and where they visit. Okay, and you can see that this person lives here and they've been to these different places. Okay, some of them are not on rivers, some of them are, and they've been to them different numbers of times. And it looks a bit odd, actually, because notice that the place they're visiting most is a real long way away. That's quite a high cost to get there. Why is that? Well, what we're going to do now is link other data sets in, such as data sets on water quality. And immediately you can see why this now is actually a logical thing, because the site that's really close to them is horrible. It's an open sewer. Okay? Even this one here is still not very nice. This is gorgeous over here. And that's why they're going there. In other words, what you can see is they're taking on higher costs to obtain higher quality. So they're actually prepared to pay for quality, just like you are every day of your life when you go into the supermarket. Okay, we can analyse these visits, and we've got huge amounts of data here. So we've got data from about 250,000 households underpinning this. So that's a lot of data. And what this allows us to do is to look at that trade-off between cost and quality. In other words, we can work out the value to people of quality just based on their behaviour. We don't have to ask them any crazy questions. We just look at their behaviour. And we can actually work out what the value must have been to them for their behaviour. Okay, and we use this, these models then to actually work out the value of recreation across the whole country. Now, here's a map of that recreational value. Now, I don't know how well you know the UK, but what we're seeing here is that the high values are not evenly spread. We've actually got high values in certain places and very low values in other places. Why is this? Well, it's because, obviously, population is not evenly spread either. We've got a lot of people here and here and here, and not very many people here, which tells you that actually the really valuable recreational locations are not those remote, fabulous locations, because although we really love going there, we only go there sort of maybe once a year, once every 3 years, that sort of stuff. I bet this is true of your life as well. You probably can think of somewhere absolutely fabulous that you love to go to, but you haven't been there for 2 or 3 years. Why? Because it's a long way away. It costs a lot in time and money to get there. All right? Whereas there's places that are just down the road that you go to a lot. So actually, ironically, it's those, when you look at people's behaviour, it's those local places that are really generating a lot of the value. And when we actually look at changing things, we find that changing things further away generates lower values, the greens, than changing things really close to where people live. So actually, if you want to improve the recreational value that people get from life, don't pour all your money into the national parks. I know that sounds like a nasty thing to say. It's not a popular thing to say in any country. But actually, put your money where people live. Improve the local environment. You know, put a park around here. You'll go to it a lot more. All right. Other things that...
Put more money into Hampstead Heath than Ben Nevis.
Yes, absolutely. Yes. Yeah, because you'll affect millions of people's lives. Improve Ben Nevis, you'll improve thousands of people's lives. Yeah. Other things that are in this model, looking at the impact of climate change on another land benefit, trees. Okay. Now, at the moment, on this one, I'm going to talk about greenhouse gases in a sec. Let's just talk about the simple thing that you get from trees, which is timber. Okay, and the change in climate is going to have a big impact upon tree growth in the UK. The UK, well, you can see there from 2010 to 2016. Now, you have to look at those maps carefully, but if you do, you can see there's a systematic change. And what's happening is that Sitka spruce, which is an exotic, it's not from the UK, it's actually from the western coast of America and Canada, is getting pushed off the island. It's getting pushed into the sea because it's getting too warm and too dry for it. Whereas oak is actually getting more the environment that it really loves. Oak grows better in France than it does in the UK. Why? Because it's French? No. Honestly, believe me on this. It's because it's warmer and drier here, and it loves it.
We need more cork for the wines.
We haven't got, I mean, by the time we get a lot of cork into Britain, things are going to be pretty bad everywhere else in the world. But I like what you're thinking. Yeah. So, you can see how that's going to change things. Actually, there's some really nice co-benefits of this, which we'll come on to. Sitka spruce is really bad for biodiversity. It's an amazing tree. It actually kills other plants around it, but that's not very good if you're interested in those other plants. Okay. Greenhouse gases. Okay. When you change land use, it has multiple effects on greenhouse gases, and all of these are captured in the model. So, for example, it changes the rate at which plants grow. That, in turn, changes the rate at which they store carbon. Different plants, particularly different trees, when you cut them down, go to very, very different end uses. So that Sitka spruce that I was talking about, it goes into cardboard boxes and stuff like that, and yeah, and all the carbon's back in the atmosphere really fast. Whereas if you're planting oak, it stays in the carbon stays sequestered for a really long time. It affects soil carbon. Different activities have different machinery requirements, different emissions. And of course, the one that really matters is whether you're running livestock or not, because that generates huge amounts of greenhouse gases, in particular methane. So switching between these end uses makes a big difference to the amount of CO2 equivalent that you're taking up each year, and you can monetize that. There's a whole host of papers that have tried to work out what the value of storing carbon is. So there's plenty of estimates of what that's worth. All right, now all those things so far are fine because we can model them, quantify them, and then value them. What about something that you can't value? Well, I don't think you can. Biodiversity. Well, you can still model it. You can still look at the impacts of land use change on biodiversity. So you can show, for example, that when you move from an extensive to an intensive agricultural system, it's bad for almost all biodiversity. And also you can see that climate change is bad, particularly obviously for native endemic biodiversity, which is going to suffer quite a lot. So there's an impact on some bird life in the UK over the next sort of 50 years. All right, now we have looked at all these different things. We've looked at agriculture, we've looked at timber, we've looked at carbon, recreation, all that sort of stuff. We can now begin to use this to answer some questions. And one of the questions that the government has been asking us is, where should we plant new forests? They want to plant new forests. In fact, if you're following the British election, which is an incredibly depressing thing to do, but if you were, you would be amazed at the beauty contest that is going on between British political parties about how many trees they're going to plant. Okay? So the Conservatives got in first and they said they were going to plant 30 million trees. And then the Liberals said, well, 30 million, we're going to plant 60 million trees. Okay? And then the Green Party said, we're going to plant 700 million trees. And then the Labour Party came in and said, we're going to plant 2,000 million trees, 2 billion trees. I don't believe any of it, but anyway. They probably will plant some extra trees. And so they've been asking us, where should we plant them? And we said, well, yeah.
If you want some time left for a few questions.
Oh, yeah. All right, I'll finish straight after this. All right. Yeah, this is a good place to finish. We said, we'll answer that question, but we'll also answer another question. And we'll start with that other question. What would happen if you planted the trees in the normal way that governments do, which is that they just set aside some money and then just throw it out there? Well, what's actually happening there is that you're allowing the planting to be determined by market prices, by really just two things, the subsidies and the agricultural value, because the timber value is not very big, to be honest. So where is this going to be taken up? Well, it's going to be taken up in locations like this. Why? Because these are the locations that have really low agricultural values. Okay? Does that mean it's a good place to plant? Well, actually, when you do the analysis of this, and you include the effect on recreation, you include the effect on carbon, you include the effect on water, you found it's a really bad idea. Actually, the subsidy cost is bigger than the benefits that's going to come out of this. Why? Well, for one thing, these places are really remote, so forget about any recreation benefits. They're also really bad for sequestering carbon, which is ironic because this is why they're going to plant the trees. Most of these places have got peatlands underneath them. If you take a tree and you put it on a peatland, the only way you can stop it from falling over is to drain that peatland first. And that means that you emit more carbon than you will ever store in the tree. You get global warming forests. Okay, alternatively, what you can do is take into account all of these things here. So the values associated, yes, still do agriculture and timber, but also the values associated with greenhouse gases, with recreation, with water quality, and we're going to put a biodiversity constraint on. We can't value biodiversity, but we can say, right, any place where planting is actually going to reduce biodiversity, and there are some places like that, then you're not allowed to plant there. Okay, so we're not valuing it, but we are making sure it's part of the decision. And when you do that, do we plant in the same places? No, totally different places. You don't plant on any peatlands anymore. You plant near cities to get the recreation benefits. You also make sure that you have no impact, no negative impacts on biodiversity. What it actually means is that net, there are positive impacts on biodiversity. And what happens to the cost benefit? Massively positive. Okay. I think I'm going to stop there. that sort of, I hope, illustrates that you can do this, and it gives us a little bit of time. I don't know, 10 minutes, 5 minutes? Okay, thank you. Thank you, thank you. Is there any questions?
Thank you, Professor, for this very nice presentation.
Thank you.
I would like to come to the concept of value.
I'm sorry, my ears are not very... I went
Yes,
to a lot
I
of very loud
the,
music when I
to
was
the
young.
valuation, economic valuation
Yes.
process and approaches. Yes. I want to say that there is the way there are many conceptualization of value of nature and its benefits and the definition of what's good quality of life. And there is also multiple worldviews and multiple system of knowledge.
Yes.
The way you, as an economist, value natural resources is different from the way a biophysician will approach the value, but they will be talking in terms of value.
Yep.
And it will also be different from the way an aborigine or an indigenous guy approaches value. This leads to multiple values and multiple approaches to value. And we would also see that you have measurable aspect of natural resources and non-measurable one. And the understanding will also differ from worldviews to worldviews and from system of knowledge. I'll take an example. In Congo Basin forest, you have indigenous pygmies who live in forests and who consider forests as their world, their heaven, as their god, and who have a very particular relationship with forests. And with a sort of maybe reciprocity and respect and all these things, that economic approaches will fail to put some value on, as they will not understand the concept of willingness to pay or the concept of maybe travel cost method, as they run in the forest all the time and they don't care about time on this. Mm-hmm. You also have these values that have to be recognized, examined, articulated. Yes.
Can you come to your question?
Yes, and elucidated. I'm just trying to hear what would you say about the position of economic valuation within the valuation process in general. Yeah. Should economic valuation walk into a basket of methodology that need to work all together in order to aggregate, to integrate, and to bridge what is not aggregatable? Yeah. Thank you.
Okay, so my quick answer to that is yes, but I think you want more of an answer than just that. So what are we actually doing here? First of all, these are not my values. These are the values that are reflected from society. Okay, so if you think about the example that I chose with regard to recreational value, I'm not putting that value on it. All I'm saying is people behave in these ways. It makes, actually there is one assumption behind that. And the assumption is that these people are not crazy. That's the only assumption in it. That they're making these decisions because it reflects their own preferences. Yeah? And they prefer, what we see is that they prefer to go to cleaner sites than more polluted sites. Okay. And from that, it is just simply, whether you believe in mathematics or not, that a number comes out of it. But you're talking about something more fundamental. Should we listen to society's values in the whole, or to individuals? And the economic approach is more of a societal approach. Nevertheless, you know, one of the problems that you'll encounter is that you will encounter some groups that hold very, very strong values, very, very strong. You know, so I work a lot with ecologists, and they believe that, for example, you know, a certain bird is of enormous value to them. Okay. Should we allow that one group to in effect veto all the others? The problem with allowing that is, come back to the very first point on the very first slide. We do not have infinite resources. Because if you say you can never do anything, for example, that causes any environmental injury to an area, then we have to stop building hospitals. We have to stop the transport system that we have. So life is always a trade-off between the two. But society has, so I think I'm generally saying this is almost a democratic sort of approach, but society has said that there's some things that it will allow to veto other things. So it has said that it doesn't want species to become extinct. If society says the people in the Congo must be allowed to have that, then you can build that in as a constraint on the system. But what I would say is that if society doesn't say that, it won't be reflected in there. So this only reflects what society thinks. It's not determining what that is, but if society doesn't care about the indigenous people in the Congo, then that will be reflected in here. Yeah. Yeah.
Yeah, I guess it's a question partly about what society thinks. So I appreciate that you might want to focus your actions on places where lots of people live.
Yeah.
But say in Australia, and I think anywhere, we have a federal system. Same is true in America, where countries, or sorry, states which have small populations get disproportionate says in, say, the Senate, because we sort of recognise the fact that there has to be some sort of equity.
Yes.
But I think to add that as like a constraint would be to miss what it really is about, because so you could incorporate those sorts of constraints in this, like everyone gets, you try and like bias it away from unequal distributions of benefits. But that would miss the fact that what's happened has been like a negotiated compromise between many groups. I don't see how that process of compromise, which is what like democratic decision making is all about, can be inputted easily into these sorts of top-down maximization prioritizations. Do you have any ideas about how you could do it without sort of just putting it in a different way?
So I'm really glad you. Oh, I've just messed my slides up. Hold on. I don't really understand Apple. Sorry. I have got a get out clause somewhere, but I don't know where it is. Sorry. Oh, here we go. Okay, so can you see there? Notice that all of this goes into the appraisal. That then goes into the decision. And the appraisal and the decision are not the same thing. They would be the same thing if I thought that what I did was perfect and it captured everything. Yeah. And just like natural science, we have to be humble. And economists have to be humble and admit that even when you try your best, you're not going to capture everything. And that is exactly the same in natural science as well. We are limited in our knowledge. So that skip between appraisal and decision is actually very important. And that's the point where a decision maker can look at this information and say, okay, that's helpful, but this decision, for example, will impinge upon the people in the Congo, maybe Aboriginal populations, that sort of stuff, in ways that I'm not happy about. In effect, one way that you can think about it is almost like weighting the decision according to other preferences that aren't captured in this. And I think if we pretend that we're going to capture everything in the appraisal, we're really doing a disservice to the fact that I do think this is better than what we're doing at the moment. Because what we're doing at the moment is missing most of this. But it is not the same as the decision. And if you, for example, have concerns about, well, I'd call it distribution, other people would call it equity, then those have to be incorporated in that skip between appraisal and decision. All right.
Okay, thank you.
So,
for the sake of time, I suggest we stop now and we can...
thank you.